So you can see here surface tension. In that I told you people, surface tension definition, if it is asked in the examination, means of course this is the standard definition. Property of liquid due to which force of liquid, free surface of the liquid tends to have minimum surface area and acts as a stretched membrane. Okay, for a very minute object, liquid doesn't allow them to go inside. For example, ant falling on the water, very minute or very lightweight object, when it is made to fall on the water surface, it floats. Why? Because water acts as a stretched membrane and it's capable of holding that. If you just make the weight of the object more heavier and drop, means of course surface tension of course cannot come to roll over there. Just why I told you already, right? Yes. Next, even in case like how to explain that surface tension in terms of equation, means normally the equation will come like this. So the definition of the surface tension in terms of equation you can see there. That is, surface tension is equal to tangential force per unit length, F by L. Okay. So standard way of defining, acting normally on the either side of the imaginary line. Look at it. Either side means upside, downside. On the imaginary line, look at it. Horizontal imaginary line is there. Diagram. Yes. Imaginary line. Okay. Drawn on surface of liquid is given. So T equal to F by L, Newton per meter. So formula SI unit and dimensional formula also I have mentioned here, students. So this is all about surface tension. Okay, fine. So surface tension definition is over. Now let us go for, so equation SI unit is fine, right? Illustration, that means examples of surface tension, let us discuss. So I will erase this. Examples of surface tension, very interesting, okay, because in day-to-day life we will come across this, okay, but we won't be knowing about this, correct, like how it is possible. So let us see. So this is one of the very important kind of property of liquid, as if like already we have discussed about viscosity, all those things. Yes. So surface tension, that means illustrations. Of surface tension. Illustration of surface tension. Okay. So what are the illustration of surface tensions? First one, best example is already I have given. Dewdrops, raindrops. For example, one like small drops, okay, or small drop of any liquid. Correct? Dewdrops, raindrops, small drops. Okay. Or you can take oil or drops of molten metal. Okay. Small drop of oil or molten metal. I told no, lead shots. Small molten metal. All these will attain what? Spherical shape, correct? Once it starts raining, the water drops always will be having the shape, spherical in shape, correct? You can see slowly, if you like suppose imagine it's raining and you have used high definition camera, slow motion camera, and you checked the shape of water droplet, always it will be in spherical in shape. Why spherical in shape? Because water tries to minimize its surface area because of the concept of property of what? Surface tension. It behaves as a stretched membrane. That is why it looks spherical in shape. So one of the best illustration is dewdrops or raindrops or small drops of oil or molten metal are spherical in shape due to surface tension. okay, or spherical in shape, correct, due to surface tension. Why spherical? Because sphere attains, why? Attains minimum surface area, correct? Sphere attains minimum surface area, okay, that is a reason behind it. Why sphere? Okay, like that. Second example or illustration. First, best one is dewdrops, raindrops, or small drops of oil, whatever. Okay. Next, free surface of water, let us take, can support, I told already, pin, all those things, support like small objects such as light metal pin, okay, light metal means it is not light, that light means very less mass, okay, light metal pin though its density is more. Why? Because of surface tension, correct? Because of surface tension it supports, okay. Next, so free surface of water can support light metal pin through its, though its density is more because of surface tension, hence surface of liquid acts as stretched membrane. Okay, take down neatly illustration of surface tension. Okay. So next, some other like best one, that is oil rises in wick. Yes, wick means batti, correct. Imagine a lamp is there, okay, and that lamp is actually not nowadays lamp with rechargeable battery, all those lamp olden days, for example kerosene and all, they will be used, and there will be, for example, a cotton cloth, a part of cotton cloth will be made in the shape of a thread, and it will be dipped. So when you light up, it lights up, correct. So continuously 1, 2, 3 days, something like that, it will run, and finally when the fuel or in the sense the oil inside the lamp is finished, it will be over. Even same happens in deepa, correct, diya we usually say. So there also, there you have what you have supposed to take is a wick means batti, okay, and then pour this one oil, then light it up. Though you don't dip it, slightly if you dip also, what happens? Oil will go to the tip of the wick. Why it goes? Who told it? Yes, oil has to go to the tip of the wick. Is there any science behind it? Of course, science is nothing but surface tension. Okay, so what happens there, inside the wick means batti, right? That wick is there, right? Batti, you know, right? Deepa the batti, yes. Inside the wick, there will be small, small pores. Pores in the sense, small, small gap. Right. In that gap, when oil comes in contact with the one part of the wick, there will be a large number of small, small pores in the wick. So oil tries to minimize its surface area, correct? Because of the gaps, what happens, the oil will feel difficulty. In the sense, it's a natural phenomenon. The oil will try to minimize its surface area. That means it tries to cover the pores. While going on covering the pores, in order to reduce its surface area, it starts to move from one point to another point of the wick. That is how it raises. Correct? It raises because of the surface tension concept. Hope it is clear now. So oil rises in wick because of surface tension. How it rises, I already told you people, because here I cannot give you all the explanation about it. How it rises is small pores between the threads due to surface tension. Okay, so in the small pores between the threads, many threads will be there, right, in the wick. Small pores will be there. So what happens when oil goes there, a gap will be maintained. So in order to reduce the gap, oil will try to minimize its surface area. Because of that, how many air gaps will be there in the wick, for example? Many will be there. So it goes on making that, okay, like minimizing surface area. So that first gap, second gap, like that. So that's how oil will rise in the wick. Okay, yes, 3 examples we discussed, right? Let us go for a few more. 3 over, write down neatly. Next, thereafter, one of the best one, okay, 4th illustration on action of detergent. We'll take that. Okay, surface tension we'll do like don't want. Okay, we'll take. That is also one of the example of action of detergent is because of surface tension. Peculiar, right? Action of detergent. What is that? Surf excel, area, so many things are there, right? Initially what we do, we will take a bucket, or usually washing machine will be there in everyone's house. We have to put surf or some whatever the detergents. What the detergents will do, in TV shows and all, they will show some animation, some punch and all will be there, like for dirt, and somebody will be washing inside in the animation. Not like that. Here what happens, whatever the dress you put for washing, which is might be having some dirt, okay, mud, all those things, or grease or oil content. So when these grease, mud, everything will be there, water cannot wash them. Why? Water doesn't get in contact with the oil, grease, all those things, because force of addition will be less along with them, because they doesn't mix because of different density. Now when you add detergent, what happens? Water, when it tries to go through the fabrics of the cloth, oil will be there, dirt will be there. Water cannot go there because of it tries to minimize its surface area, first of all, correct? It already has got its own surface tension value. Once you add detergent, what happens, the water will get reduced with its surface tension. Surface tension of water gets reduced. Now what happens? The property of behaving like stretched membrane reduces. So what happens, the molecules of water will go wherever it wants. So finally what happens, the small fabrics, that means nulu, right, fabrics like this, it will be there inside the cloth. There, in between, everywhere it will go, and it washes nicely. So detergent why we are adding is for this sake only. Okay. So why we are adding detergent is, of course, detergent contains some soap kind of particles also, all those things. They will give nice aroma, washing, everything. But main property of detergent is when detergent is mixed with water, you cannot wash any dirt cloth just with water. Clean agudilla chanagi, correct? Slightly some dirt, grease, all those things will be there. Put detergent, what happens? Detergent will reduce the surface tension of water, and water will be capable of going through small fabric portion by getting reduced with the surface tension. Okay, that's how we can explain about the action of detergent. That is also one of the example. Action of detergent is because of surface tension. Okay, so action of detergent is because of surface tension. Okay, so what happens here? On adding detergent, it reduces surface tension of water, reduces the surface tension of water. So tension of water, so water in the sense along with the soap particles, okay, will penetrate, particle will penetrate through minute or fine fabrics, okay, through interior of the cloth is enough. Interior of cloth and cleans it. Yes. So this is the fourth, what we can say, example. Okay. So next, one more I can give you. Last example, okay, easy one. When paintbrush immersed in water, the hair of brush, you know, right, many of you will be having the drawing hobby, all those things. The paintbrush is there, when you dip inside water it spreads, okay, hair of the brush spreads, correct, it spreads. Next, okay, when it taken out, hairs will cling. Cling means getting together, okay. That means the hairs will cling together. Cling, C-L-I-N-G. Why? Because of surface tension. Yes, it's the fifth illustration, okay. Because of surface tension. Okay, students. So here what happens, you know, so once you dip inside the water, what happens? Brushes will spread out. Once you taken out, what happens? There will be a fine gap, right, in between the